In this video we will learn how to make a simple LED flasher that works with a voltage as low as half a volt. The circuit is a variant of the blocking oscillator, also known as the Joule Thief. It works with a voltage between 0.6 and 3 volts. We will need a 100 kilo ohm resistor, a capacitor between 1 and 20 microfarads, any NPN transistor, a couple of LEDs, and an inductor that we will see in a moment how to build. We will now see how to make the coil. For this, you need two pieces of magnet wire, each of about 3 meters in length. We will twist the end of the wires to identify the start of the coil. Next, wind the magnet wire around a cylindrical object that is about 2 centimeters in diameter. I am using a C-size battery. It is convenient to use a piece of tape with the sticky side upwards. Take the wire from the side where you made the twist and wind 30 turns. After you finish winding the 30 turns, take the coil out of the battery and wrap the tape. It is important that the coil is as tight as possible. Don't forget to remove the varnish from the ends of the magnet wire. It is important to identify the wires that correspond to each of the two coils. You can use the multimeter to check for continuity and make the identification. And I have used red and black wires to label the coils. Both coils begin here and end here. Therefore, this is the beginning of the first coil and its end. And the second coil begins here and ends here. This is the circuit on protoboard. I am using a transistor that is a BC547. This transistor, the pins are collector, base and emitter. The delicate part in building this circuit are the connections of the coils. Let's see it in detail. Suppose that this point is the beginning of both coils. Therefore, here we have the red beginning that is connected to the base of the transistor, and the black beginning is connected to the positive of the capacitor. Now, the two ends, we have the black end that is connected to the collector of the transistor and the red end that is connected to the negative of the capacitor. Now let's see the circuit in action. Let's check our circuit. We have it connected to our power supply, and let me turn it on at 1.5 volts. We can see the LEDs flashing. The flashing speed or frequency depends on the value of the capacitor. A larger capacitor will produce a lower frequency and vice versa. This circuit also works at a lower voltage. Let me move it down to 1 volt. It still works, and if we move it further down, 0.7 volts, it's still working. Let me try at 0.6 volts and 0.5 volts. We still have flashing on the LEDs. This means you can use this circuit from a almost depleted battery.